So, hey guys, so we're going to do a layout critique and a design critique of a board I did some 3 to 4 years ago. So this was for a speed governor. And yeah, so the first thing, the schematic, difficult to read. Yeah, so this could have been done better. For instance, we know, let's say power is here. Here you're seeing NAND flash and our power component. Level shifters all over the place. That could have been done better. Yeah, sort of a problem. So this thing here, this is a Simcom SIM868. Yeah, problems. Let's go to the PCB layout. So the first problem I see is this mounting holes. So these mounting holes are actually outside the board's boundaries. That's a problem. It's actually outside the board outline. That's a problem. So of course that should have been better done. I think what I was trying to do was I was trying to design around the internal shape of the enclosure we had purchased. And me mishandling that sort of brought up this problem. Another thing, I'm not very comfortable with this buzzer being near this GSM. Sort of, I think this is inductors and it can, a very sensitive area here. I sort of think it should have been kept away because you don't want any electromagnetic interference, because it's like a PWM driven. So you actually don't want any electromagnetic interference from that buzzer coupling with this. Let's go to the power. So here it's a bit of a problem. You've seen we've used these point-to-point connections, particularly pin 2. So pin 2 of this LM2596. Pin 2 is the output network. So between that diode and this inductor, this area here, you have a lot of, how can I say? In this area marked here, here you have what we can call the power. So power traces basically. So here we have it's a very sensitive place and which can radiate like nonsense. So this is a very sensitive area, right? So it's called like this loop here is a very sensitive area. So with this sort of routing, point to point, very high inductance and all that, what you will notice is that you will have very bad power regulation. Also, there's a capacitor that's supposed to be here, C45. Where is C45? Or C47? I can't see it. I cannot see that output capacitor. Oh, here it is. I simply cannot see the output capacitor. It's also C47. Where is C47? You see, even the routing is so badly done. I can't find C40. It's C45. C45. Anyway, I think the designators were reset. But there's supposed to be an electrolytic capacitor there. It's not there. So this section, the routing is quite bad. So what you're going to happen is you're going to have a lot of voltage ripple, problems with regulation, and also a lot of radiation, right? So because of this sort of routing, so you're going to have a lot of radiation. These things generally have layout guidelines. There's also an application note you can check out, AN1449, so layout guidelines for switching power supplies. You can have a look at that if you want to improve your layout for switching power supplies. But in general, that sort of layout is very problematic. It will cause problems. This module here can draw up to 2 amps when it's trying to start up. So, I mean, in that situation, what can happen is that you can find yourself losing regulation because it's a high load current. So you can lose regulation. You have a lot of ripple voltage, a lot of ripple in your output voltage. So it's very bad, and a lot of electromagnetic interference. So this circuit here can be very noisy. So that noise can go and couple with other sensitive circuits, and then it just becomes a mess. Another thing, we are doing some analog measurements. I personally these days would have separated analog ground and digital ground, sort of given that segregation. If we were doing measurements that may be a bit sensitive, there is no segregation here. RF sections. So this area here, I don't see any stubs. Yeah, there are no stubs. That's one thing. I didn't use these fat traces because we don't have a proper ground plane. So I was assuming that the polygon, the ground pour here is what I'm using as my reference. Not a good idea. So with this sort of setup, what I actually would have recommended is using a 4-layer stack-up. So why we use the 4-layer stack-up? Boards are not expensive these days. So this is the stack-up that I recommend. So you have signal, L1, L2, ground signal. So the logic behind this is that on both layers, we have a good reference plane. Yeah, so that's how, of course, I'd improve this layout. So change the stack-up, sort out these mounting holes, and then also check this thing, because it's not just that regulator here. Also the boost regulator circuit, we're seeing a lot of point-to-point connections. These are high inductance connections. You can see there's a very long trace coming from VBAT here. Again, very inductance. Inductance is the problem at all time. We have this inductor is so far from the converter IC, the converter controller IC. It's very far. This is a very, very high inductance path. So obviously, this thing at some point, if the load current goes high, again, we lose regulation, we have a lot of ripple, we have a lot of radiation. So that is a problem. Very badly designed power section, but can be corrected. No, first time for everything. So this was me 3 years ago. So yeah, those are the things I'd correct. Here, yeah, nice fat traces. So low inductance can take a lot of current. Again, we'd move these decoupling capacitors closer, sort of make sure that the connections are done with very fat traces, so low inductance. Where is the MCU? I think the MCU is on the other side. So let's go to L2. So let's see how it's been done here. Again, the silk screen also, you know, the silk screen, okay. So we have, again, we could have done fatter, bigger traces, low inductance here for the power decoupling. Yeah, things could have been done better. We're seeing there's no spacing in between the traces. So these are analog signals, so there's no spacing. It's best to space them out a bit because we're using the minimum spacing. If I can just measure the distance, it's quite tiny. It's quite tiny. I don't know, but just from looking at it, it looks a bit tiny. Having issues measuring it. Let me go to the snap grid. Anyway, I always maybe space things out a bit. Things are a bit close to one another. All in all, this layout leaves a lot to be desired. But anyway, that's what growth is for. That is what growth is for. Yeah, you have a buzzer very close to a SIM card. Yeah. So yeah, leaves a lot to be desired. But anyway, it was 3 years ago. Now we know better, and now we're able to critique it. Anyway, have a good day.